Welcome to our capstone presentation. We worked with Clay and Michael from Humana Machina on this. It's titled Natural Language to Structured Logical Query. My name is Cody Falconer.
My name is Christian Barajas.
I'm Claire Longsworth.
I'm Sebastian Echeverria.
And I'm Israel Fernandez.
So our project description. Converged mixed reality 3D models consist of multiple layers of textures, each with its own embedded metadata. Every layer holds important information such as wire location, fastener numbers, and panel locations. Currently, it is very time-consuming and inefficient to manually process through the data to retrieve the information that you want.
The way that Humana Machina currently has it set up for its converged mixed reality 3D models is that the operator needs to know which panel or which different types of attributes that they will be looking for, and they need to keep track of that and then insert that into their 3D model structures to be able to get the exact 3D model that they're looking for. And so our objective is to simplify that process for the operators, so the operators can just use natural language to query their converged mixed reality models. And the benefits of that is that it offloads a lot of that complexity of needing to memorize the attributes of every single model, and they just request what they're looking for, and it gets returned back to them.
As for our project solution, we originally had a couple of plans that we were thinking could work. One of the main ones was using an LLM to process the query and get it into that structured format we want. And if we use that method, we would have to minimize hallucinations, which caused some issues. And it tended to be pretty non-deterministic, so we would get different outputs for the same input, which obviously we don't want because we should be getting the same one consistently. Another idea we had was to use pre and post processing with Python libraries like SpaCy and Fuzzy Wuzzy in order to parse that natural language and then convert it into the structured query manually. That was kind of like, it would have a lot of moving parts, and so that made it a little bit more complicated, and it would take more time because of those parts that we had to combine. And so we found it wasn't as efficient. It would have too high of a latency for the user. And so our final idea was to do a hybrid approach where we use an local LLM and fuzzy searching as well as some pre-processing with Spacy in order to kind of combine those things. But we found that that also was a little bit too complex and it couldn't handle large data or large schemas like we had, as well as our final approach.
For our final approach, our plan was to import the JSON schema that would have all the information for all the fields and keys, and then use natural language to process this. Because of the fact that the actual schemas were big, our LLM could not handle all the data. So we created the multi-layer search algorithm, which would extract information from multiple areas, keeping the context low and allowing the LLM to process the small amounts of data. This will make it, in the end, it would make it longer, but it would make it more accurate. And the flow goes as import schema and natural language query that you are looking for. The multi-layer search algorithm would process all the information. It would look for the highest relevance in the query. And then with all the data, it would create a structured logical format that would be returned back to the starting point, which would be the graphics user interface. And then that would be it. And so here you can see where we have the option to select a schema and then importing the schema as a JSON file. And then you can give it a query as give me panel 41L. And then it'll tell you once it's done. And then the output would be F0 is equal to K199, which would be correct.
Yeah, so in conclusion, I think we took away a couple key benefits from this. We made it more accessible for people who don't exactly know the schema inside and out to get those queries that they're looking for via natural language. We also made it easier for users to just discover information across the 3D models in general via natural language, because it kind of removes the barrier for having to know the schema there. The impact that we took away, I think we demonstrated successfully that we were able to translate the query, given that previous slide there. We learned that local LLMs there's a few kind of caveats that come with them. They're not super easy to work with all the time. They're a little bit unreliable. We also found that breaking down the steps that we were giving the LLM into smaller kind of chunks made it a little bit easier to tackle those challenges. And I think we did a good job of kind of working with the resources that we had rather than throwing it at a really powerful solution. Yeah. Yeah, so thank you for watching your presentation. I would like to send a special thanks to Clay and Michael of Humana Machina. They were great mentors throughout this whole project.